Hello everyone. Today's video will show you how to package your own RTL IP and integrate it with the Microblaze processor. We will also show you how to display your computer's input on our Basys 3 board using the 7-segment display. First, let's quickly build our project. If you are not familiar with the basic Vivado flow, you can check out my first video for more details. Create a clock source and our Microblaze processor. And we also need a UART port. Next, since we cannot simply use the Microblaze to control the 7-segment display, we need to create our own RTL to handle the display's control. So let's click Tool and click Create a Package New IP. Click Next. Then select Create a new AXI peripheral because we need to connect this IP to our Microblaze processor via the AXI interface. Click Next. We can rename our IP to Display Control and click Next. And finish. Our IP has now been successfully registered in the repository. To add it, we can select Add IP and type Display Control. At this point, the IP only has an AXI interface and no functionality. We need to define its function and add more ports. We can right-click the IP block and click Edit in IP Packager. Click OK. Now we can see here is a wrapper with the AXI interface, and we can add some user code here. We can copy the code from my website. We first need more ports for the 4-bit anodes and the 8-bit 7-segment LED. We call them AN out and SG out respectively. And at the bottom of this module, here we can add our logic. Similarly, we can copy the code from my website. Here, I have defined a module called Display Decoder to decode the input digit and drive the corresponding 7-segment display. This AXI wrapper includes 4 32-bit registers, each with a unique address. We can access them through the Microblaze processor. Register 0 is used to store the anode information, while register 1 is used to store the information for 4 digits, each digit stored in an 8-bit format. Then, we need to include our user-defined module. Right-click the Design Sources and Add Sources, and click Create File. We can name it as Display Decoder, and we save it in the same folder as this IP. Click Finish. So now we have our empty module. Again, we copy the code from my website. Now, let's take a look at this code. First, we have a 4-bit anode input and 4 8-bit digit inputs from the AXI interface controlled by the Microblaze. Then we have a 4-bit anode output and an 8-bit 7-segment displayed output connecting to the Basys 3 board. Here, we define the relationship between the input digit and the 7-segment display code. I have commented on the corresponding position for A to G. If you are unfamiliar with the 7-segment display rules, check the Basys 3 manual. Then here is a digit decoding. According to the input digit, we can decide the 7-segment display code. And we use the same structure for each digit. And here we define an 11-bit counter to count 2048, which reset every 50 kHz. Using the 50 kHz counter, we use the most significant 2 bits to switch between the 4 anodes. And we use the input A and in to control which anode can be turned off. Last, we use the same 11-bit counter to display the 4 digits in turn. Lastly, we need to add the additional output ports to our IP wrapper. Then we can run synthesis to check if our IP is all good. Then in the package IP here, we need to review and merge all the changes we have made. Then click Repackage IP. After we come back to our main design, we can click Report IP Status here to update our IP. And then click Upgrade Selected. Here are some errors because I forgot to connect our IP. Let's click the Run Connection Automation. Lastly, we need to connect our AN out and SG out to the 7-segment display on our Basys 3 board. Right-click the port and click Make External. Then we need to add a constraint file for those 2 output ports we created. Right-click Constraints, select Add or Create Constraints. Let's add a file here. You can find this file on my website as well. So let's take a look at this constraint file. Here, we assign the ports to their corresponding pins for the 7-segment display. Then we create our HDL wrapper. We can validate our design, and we can finally generate the bitstream. After generating the bitstream, we export hardware. And we launch the Vitis IDE. We create a new platform under the number 3 folder. Select the XSA file and finish. Build our platform. And create our application. Here we can also copy the C file from my website. And rename the C file. Let's take a look at this C file. First, we write initial values to the AXI registers. For register 0, use the bus address of this AXI component. For register 1, use the bus address plus 4. Next, we create an infinite loop to continuously sample input from the computer's keyboard. The receive byte function fetches the input in ASCII code format. We then subtract 48 to convert the ASCII codes to integers. If the input digit is outside the range from 0 to 9, this will reset the display numbers to 0. We store each digit in the 32-bit data. Each time a new digit is received, this data shifts 8 bits to the left, placing the latest digit in the LSB. Finally, we write the 32-bit data containing the 4-digit information to register 1. Let's build our application. Connect your Basys 3 board. And we can see the result displayed on the 7-segment LEDs.